November 29th. Here we go. All right. It is November 29th. It is a Monday. Happy Monday, ladies and gentlemen in the interwebs. We are going to review our review slide together. Take us away, Mackenzie, please.
I got 9/8 by doing 1/8 9 times.
1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Raise your hand if you enter an agreement with Mackenzie. 1, 8, 9 times. Good job. Did anybody have that? Did anybody also have that? I did see some of those. Very good. What else you got on there, Mackenzie?
4/8 plus 5/8 equals 9/8.
Who else has 4/8 plus 5/8 or 5/8 plus 4/8? Good job. And finally,
6/8 plus 3/8 equals 9/8.
very good. 6/8 plus 3/8. Anybody else got that? Very good job. Hey, one thing I do want to point out, and I've noticed on some of your review slides, some of you are leaving these out. You're just making lists of fractions that equal 9/8. Your list of fractions that equal 9/8 are correct, but the question is asking for a sum. In order for you to provide a sum, you have to show that you are adding. Very good. So you have to show that you have a sum, which is why you have to have these addition signs, okay? Review slides looked great today. Super, super good. I was very, very pleased. Good job. You and the last class did a good job of remembering what we talked about before Thanksgiving. So, well done. Thank you. There. Okay. So we know all about how to add fractions. You guys are doing a great job with that. Your take-home practice packet has more practice. So if you need more practice, you can do that. One thing I haven't mentioned that is a good time to mention during a recording, if you need more practice of what we're doing in class, go home and get on the practice poster. You can do that at home. You could get a streak of 500 at home, I bet. Wouldn't that be cool? You got a streak of 500 on the practice poster?
What if I well, you know how you said that
you want to bring me a streak of 500? I'll get you some kind of prize. If you bring me a streak of 500, mark it down, 4th graders. You bring me a streak of 500, I will find you some sort of prize because that would be prize worthy. I'll give you that.
all right.
Let's explore differences of fractions on a number line, shall we?
Yes, we shall.
What does it mean when it says differences? What even is that? Olivia? The answer to a subtraction problem. The value of a subtraction problem. Very good. Okay, to start us off, we are going to decide if a statement is true or false. Are you ready?
Yes.
When you decide, I want you to take a thumbs up for true, thumbs down for false, and put it on your buttons. Pretend you're wearing a tuxedo. You're very prim and proper. You got buttons right here, right? Give me a thumbs up on your buttons or a thumbs down on your buttons. I don't want them to be up in the air because I don't want people around you to just look at what you do and then they don't think the thoughts for themselves. You know what I'm saying? Mm-hmm. I want your thumbs up or down on your buttons. Up, down, up, down. Here we go. Decide if each statement is true or false. Sophia, what do you think? Why do you think it's false? She says false. Why? Doesn't equal what? Okay. Who else can explain their reasoning? Charles?
I see
You're right.
3 plus 2 plus 1 equals 6. Then it won't be equal because it's not a full part.
Okay. Who can continue that thought? Complete the thought.
It would equal 6 because if you do 2 plus 3 equals 5 and plus another 1 equals 6 and 6 is not the same as 10. It is 4 lower than 10.
He says 6 is 4 lower than 10. Why does that matter? Why does that matter, Levi?
Because there's not 10 shaded in for 10 equal parts.
This one here
Means that there's 10 equal parts and there's 10 shaded in.
very good. That we have 10 total amount of equal parts, and there are 10. The number we have is 10. But this is 6/10, and this one here has to be 10/10, and therefore, Sophia was right. The answer is false. Very good. Ready for the next one?
Yeah.
Your button's not in the air. Be ready to explain your answer. How confident are you?
Very confident.
He's very confident. Go, Garrett.
Well, with 1 whole plus 7/10 would equal, that would equal 1 whole and 7/10, and then 3 plus 4 equals 7. So if you add 7 to the 1 whole would be equal 10/10 because that's how many equal parts and there's 10 shaded. So that means that would equal 1 whole, and then 3 plus 4 equals 7. So that means it would be 7/10, and then we could add, and then you could take that whole off of there, and then make it 1 whole, and then 7/10.
Who agrees with what Garrett just said? Here's a whole. Is he right?
Yeah.
Yes. Here's a whole. Is he right?
Yes.
Yes. Here are 7/10. Yes. This here would be 7/10.
Yeah.
Correct?
Yes.
So Garrett was one of 2 people that I saw. I saw 2 people that had a thumbs up. Everyone else had a thumbs down. Do you see now why it is right? Why it is true? So I appreciate your truth. I got some people shaking their head. So let's look at it again. Here's the question, right? Garrett said that this says 7/10. Does this say 7/10?
Yes.
Garrett says that 3/10 plus 4/10 equals 7/10. Is that correct? So that means these 2 things are equal, right? 7/10 and 7/10. Garrett then said that this stands for 1 whole. Is that true?
Yeah.
He also said that this stands for 1 whole. Is that true?
Yeah.
So then this whole and this whole is the same. So 1 plus 7/10 equals 1 7/10, right? Which is this part, this side. And then if we take this here, 10, let's see, 3/10 plus 4/10 plus 10/10 equals 1 whole and 7/10, which would make this statement true. Does that make sense?
Yes.
Very nicely done, Garrett. Next one. So fast. Nikki, what do you think?
I think it's false because 5 plus 1 whole, it equals 1 whole, 1 and 5 tenths, not 6 tenths.
This is the kicker right here. This is the trickster, right? It's this wants your brain to be like, oh, 5 plus 1 is 6. Done and done. Moving on. Check. Got it. Right? But you have to be like, whoa, brain. Slow your roll, my dude. Hold on a second. Let's think about this clearly. This is not 1/10. This is code for one whole thing. And this whole thing is cut into how many pieces?
10 cents.
So how many tenths is this? 10 tenths. So 10 tenths plus 5 tenths equals 15 tenths, not 6 tenths. Correct?
Yes.
Yeah? Good job. Next one. That one was easier to explain. Do you think so? Next one. Oh! What's wrong here? What's the matter, Ella?
That it says equals 1 plus 1/5 and 1 is a whole.
What else is wrong here?
So on the first part it says 2 tenths plus 10 tenths. The equal parts is a 10.
The equal parts is a 10 on this side. And the equal parts is a
5.
Not trying to give anything away, but you're gonna have to think about that. Somebody in my earlier class figured this out, so it can be done. Equal or unequal? True or false? Dun, 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 dun. True or false? No answer is not a great answer, so don't give me no answer. Give me some thoughts. Think it out. Let me ask you this. When we have an equal sign and we have different denominators, are we allowed to have that?
Yes.
No.
No, that is not a thing. Okay? So that's your first clue. That is not allowed. Show me your answer on your buttons so I can know whether or not I can call on you. And notice, if I call on you, you have the right answer. I'm not calling on people that don't have the right answer. So just be confident when I call on you. Okay. Raylyn Cornute, what do you got?
Well,
True or false?
it's true because 5 is half of 10, and so it could take 2 pieces of the 10 to equal the 5.
Stand that up, please. Don't want that spill.
And so we could do
What do we need to do? Whatever we do to the bottom, we had to do 5 times 2 to make this denominator 10. Whatever we do to the bottom,
You must do the top.
and 1 times 2 equals 12. I mean 2.
So now we have changed. Look up here, guys. Hey. You already how to do this. We did this a long time ago. Now I'm going to be asking you to put together the things that you learned, to put them together and to use them together. Okay? So when I throw a fraction at you that's fifths on this side and tenths on this side, I want you to say, oh, 5 times 2 equals 10. I can get that to be common with here, and then you'll be able to get somewhere. Now, Raylan, what do you think?
And 10 tenths equals 1 whole, so it is 1, so it's true.
So 10 tenths is the same as 1 whole. And this 2 tenths, we changed that 1/5 to 2 tenths. So now these things are the same. So now our statement is true. Very good. Okie dokie. Here we go. The nuts and bolts of our life. This is where you need to be on your screen. Have that pulled up. Next, there you go. How are these diagrams the same as the diagrams we saw in an earlier lesson before Thanksgiving? How are they the same? How are they different? I want you to take just some quiet think time. Take some quiet time to think about this. How are they the same and how are they different than the diagrams we used to use with addition? All right, I want you to take that amount of time, and I want you to share your thoughts with your table. I want your table to have a conversation.
The differences, they're different about, like, see how there's like 4 on the line, that number on the line? The difference of that is that both 2 of them are like using backwards. Okay. Looks like the equal parts are 6. And then they went 11. Whoa.
Thank you. I was trying to come up with a tune, but I couldn't on the fly. All right. How are they the same? How are they different? What do we got here? I want to talk to someone I haven't talked to yet today. Ashley.
The line's going backwards, so that means it's subtraction.
So is that the same or different?
They're all going backwards.
Right, but is it different than what we had been using in the past, or is it the same? It's different. Good. Ella, what do you think?
That there's 2 there.
Is that the same or different?
Different.
Okay. Ella, what do you think?
That they're going over the 1 to the one.
Okay.
Or they're still using numbers like the same.
Okay. Bentley?
That there's like, there's still 1 right here, but it's 5 and 2, and the 1 hole's right here, but normally it'd be like back here.
Okay.
So it's the same and different.
Okay. Hey, can someone talk to me about this? Tell me, what do you know about that? Does it belong? Like, tell me what's going on there. What's the story, Will?
The last fraction, it was 8s, like a whole number, and this fraction, it's a fraction.
Oh, we looked at a number line with whole numbers last week, didn't we?
It was like 8, and then it said 11.
Okay, sure, that's true.
It's higher than 1.
Okay. I wanted somebody to talk to me about that denominator right there. Levi?
there's six parts from 0 to 1. There's 6 in each one, and then from 1 to 2, there's 6 in each one.
Very good. Which tells us that this number line is cut into 6 pieces. Each whole of the number line, each whole part from 0 to 1 is cut into 6 pieces, right? Very good. That is what I wanted to hear. Good job. Okay. Now, how do we know that the point represents 11/6? Levi already kind of talked to us a little bit about this. How do we know, Raylan?
Well, since each thing has 6 in it, and it says 11/6, the last thing would be 12 sixes, and it's right at the end, so it would be 11 sixes.
If we count each space, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That tick mark right there is 11/6, and Raylan's right. If we went one more, then this 2 would be 12/6, correct? Everybody see that?
Yes.
Okay. Taking your word for it, right? You say yes, so I'm going to go ahead, right?
No.
Okay. Good. To subtract different fractions from 11/6, Noah draws jumps on number lines. So this is the same number line we saw on the last slide. And I had somebody in an earlier class tell me they felt like these weren't exactly the right length. And I think sometimes our eyes can kind of play tricks on us. And so your eyes might be trying to play a little trick on you, but don't be tricked. They're the same. Okay? So don't stress about that.
Yeah.
How are these? Okay, we did that. I want you to look at these number lines. The first diagram shows how he finds 11/6 minus 7/6. So he has 11/6 here. He starts here. Then he subtracts 7/6. 1, 2, 3, 4, 5, 6, 7. And he lands here. What is the value of 11/6 minus 7/6? What is the value of 11/6 minus 7/6? Bradley Bentley, what's the value?
4/6.
Who agrees with 4/6? Who thought 4/6? Bradley, how did you get 4/6?
I did 11 minus 7, and that got me foot, and the denominators are the same, so I kept them the same.
Good job. And so if we want to use this number line, we can see that he jumped back 7, and we can count 1, 2, 3 on the number line. That lands on 4/6. That makes sense to everyone?
Yeah.
Okay. Right, so our equation here would be 11/6 minus 7/6 equals 4/6, right?
Mm-hmm.
Now, on your classwork, in the classwork section of your notebook, I want you to write an equation for these two here. I'm going to give you like a minute to work on your own, and then I'm going to give you a minute to work with your partner or your table, okay? Give me an equation to show the difference represented by each of Noah's number lines. Each of Noah's diagrams, they call it. So I'm looking for two equations. Remember, the difference between an expression and an equation is that an equation has an answer, an expression does not. So I want an equation, not a number line. I don't want you to draw a number line. I want you to use the number line on your screen. You already have the number line on there. Don't redraw that. Write me an equation.
Do you want me to do it on one that already has the equation?
No, just on the second two. Not the one we already did, just the second two. All right, now take some time to talk to your table. Where does the number line start? Where does it start? How many jumps does it make? Write an equation. Share out with your table. Go.
The first one I did 11, 6 minus 5, 6 for the bottom one. And then for the middle one I did 11, 6 minus 3, 6.
I did this. I already mentioned last week. 11 6 minus 2 equals. Hang on. She said you don't have to put. Here's what I did. You don't have to put the value down. And I'm like, I counted.
I want the value and the expression.
So
An
I
equation
3
has a value. An expression does not.
11 6. So 11 6 minus 3 6.
Yeah, but your math's not right.
It's like backwards. 3 6 is
Now look here. You're starting at 11.6, and how many jumps are you going backwards? You're going back 1, 2, 3, 6. These are the jumps. So you've got these flipped. The answer is where it lands. See, look here. This is where we started. We jumped 1, 2, 3, 4, 5, 6, 7, and we landed on the 4, 6. So here you need to start here. This is how much far you jump, and this is your value. That's where you land. Yeah, she just got her numbers flipped. All right. What do we got here? Who wants to share out? What do we got, Ashley?
11 6 minus 3 6 equals 8 6.
Thumbs for agreeing or disagreeing. Thumbs up if you agree. Thumbs down if you disagree. So, Ashley, you're saying that we start with 11 6. Correct? Stop me if I'm wrong. We're subtracting 1, 2, 3, 6. And we're landing here, which is 1, 2, 3, 4, 5, 6, 7, 8, 6. Is that what you're saying? Is that what the rest of you are saying?
Yes.
Very good. Excellent. That is correct. What do you have for the next one? Sophia. 11 6 minus 5 6 equals 6 6. So you're saying that we start here at 11 6 again. Is that it? We're jumping back 1, 2, 3, 4, 5. Yes? And then we're landing here, which is 6 6. Is that correct? Raise your hands if you agree. Raylan Cornu, what did you say back there about this one? You had a very good comment that I want you to repeat to everyone.
I said, well, it's minus, and then it's got 6 6, so it could also be one whole.
she noticed right away that the answer was going to hit right on this one hole. And so before she even knew what the jumps were going to be, she knew the answer because she saw that the arrow landed on the hole. You probably didn't even know this part yet before you realized. So she already had the value figured out just because she knew it landed on the hole. That is an excellent way to take what you know about fractions and apply it to something new, which is your main job, to take what you know and apply it to what you don't know. Here is another diagram Noah draws. Study this diagram for a moment. Study this diagram for a moment. So if I was going to study this diagram, I would say, okay, we're starting here. We're jumping. We're landing here. Okay. Okay. So I've studied my diagram now. Which equations could the diagram represent? Which equations could the diagram represent? Be prepared to explain your reasoning. You don't have to use the big screen. You can use your board, use your screen so you can see it up close a little bit. I know it's hard to see up here sometimes. Everybody get a choice. Can you choose one of these? Can everybody get a choice? Make a choice here. What do you think, Bentley?
I think it's number 1 because there's so on the dot it's 11/6, so 11/6 take away 6/6 which is 6 right there.
You're saying there's 1, 2, 3, 4, 5, 6 here.
And then
so you're saying this is 6, 6. This is so the purple matches the purple, the orange matches the orange. Is that right?
And then there's 5 right there. No, there's 6 right here, so that denominator would be that.
So you're saying that this equation matches this diagram. Who agrees with Bentley that equation matches that diagram? It sure does. Good job, Bentley. Very nice. Does anybody have something else they want to say? Something you want to say, Sophia? So these here have a 1. Is that right? Huh?
So the 1 and the 6/6 equal the same thing.
What do you mean?
6/6 equals 1 whole.
You're saying...
It doesn't matter if there's a 1.
Hold on. You're saying that if I have this whole thing, this whole circle, is this one whole circle? This is one circle. Is that correct? Is this one circle?
Yes.
Yes, okay. They're like, yes. Oh my gosh, woman. Yes, it's one circle. How many pieces have I cut this circle into?
5.
6.
Yes.
2, 4,
6.
6. Thank you, Bentley. Bradley, Bentley. I was only partially wrong. Right? So my denominator here is 6. Correct? If I color in 1, 2, 3, these parts are not equal. 4, 5, 6. Sophia, if I color in all 6 of them, how much of the circle do I have? 6, 6, or 1 whole. And now what is that? How does that apply to what you're saying?
because 6/6 and 1 whole, they're the same thing, but They're the same thing.
So you're saying that this equation says 11/6, which is the same here. Yes?
It's the same thing.
And even though this says 1, this jump right here is 6/6. Is that what you said? Yes, that's what you said. And you're saying that if I cut one whole thing into 6 pieces and I've got all 6 of them, 6/6 is the same as 1 whole. Is that what you're saying?
Yep.
So which means that this is equal to 1 whole, meaning that this and this are the same thing. Correct? Yes? Are you all tracking with me?
Yes.
And so then, when we jump one whole thing, are we going to land in the same spot?
Yes.
Yes, we are, which means that equation number 2 is also correct or true. Very good.
Number 3 is also correct.
Number 3 is also correct, they say. Now I'm starting to wonder because this is pretty easy to see. If you've been following with me, if you've been understanding the fractions I'm talking about, this here is pretty easy to see. 6/6 is 1 whole. We've been doing this for a while, right? We get that. But now you're trying to tell me that this is also true?
Mm-hmm.
I'm going to need some pretty hefty explanation, Mr. Heights.
So
Nice and clear. Nothing all muddy. Nothing distraction or confusing. Clarity. Crystal. Like the beautiful water. Go.
So 5/6 is going to be the answer, and then there's 1 whole, which would be the marks, in the orange, and then now I'm not going to pay any. So don't pay any attention to the purple because the purple is not in this one. But if you add 1 whole plus 5/6, that would equal 11/6. But then if you minus
Stop. You just said very quickly. But if you have 1 whole plus 5/6, that's going to equal 11/6. I need more explanation. What do you mean? Are you telling me
6
that this and these two things are equivalent?
Yes.
1 and 5/6 is equivalent to 11/6. Is that what you're telling me?
Yes.
Okay, I'm gonna need you to prove it to me because fourth graders get some wild, hairy ideas and
Yes, a 1 whole. So the 1 equals 6/6 would equal 1 whole. Now,
the
if you
1 whole
did-
equals 6/6.
now if you multiply, wait. No, you use addition.
Okay.
So 6/6 plus 5/6 would equal 11/6 because 6 plus 5 equals 11, and then we keep the same amount of equal parts would equal 11/6. And then now if we minus that 1 whole, so
Who agrees with what Garrett's saying right here?
I agree.
Who agrees with this piece here? That Garrett is saying that 1 and 5/6 is the same as 11/6. Okay, put your hands down. Garrett, you do not have full support. You have not convinced everyone. Can we use a number line? Can I erase all the stuff on this number line?
yes.
Get us some clarity here. Oh, missed one. Garrett, can we use the number line to prove to the people that you did not win over, because you did not win over everyone, that 11/6 is the same as 1 and 5/6. Do it. You did it down here.
We can do it up there.
Do it up. You can? Okay, he's confident. He's ready to go.
So 11/6, now the arrow pointing, so 11/6 would be 1 before the 2, so 2 holes. And then now if that arrow was on the 2 and then go to the 1, that would equal 6/6. But now if I take 1 back from the 2
Hold on.
to 11/6,
Your waters are murky and muddy, man. Think about it. Try to think about it easier. You're not trying to convince them of the subtraction problem. You can't convince them of the subtraction problem until you convince them that 1 and 5/6 is the same as 11/6. You got to convince them that you're starting in the same spot. How do we convince them that this and this are the same thing? Start with the one whole.
One whole. So one whole is going to be 6/6 because the denominator is 6. Now that would equal.
Hey, those of you that don't agree, get your eyeballs up here.
That would equal one whole. Now the arrow is jumping 6.
Hold on, leave the arrow out of it.
Well,
we're still trying to convince them of this. This is one whole. Do you all see that?
Yes. Yes.
One whole is the same as 6/6, correct?
Yes.
So, our one whole in the 1 and 5/6 is the same as 6/6, correct? How many more 6s do we have to get to 11/6? 1, 2, 3, 4, 5. So, one whole, which is 6/6, and it takes 5/6 to get to the 11/6. That proves that 11/6 and 1 and 5/6 are the same. So we're starting here at 1, and 1, 2, 3, 4, 5. We're starting here at 1 and 5/6. Check. Now we're going to go back one whole, which is how much?
6/6.
6/6.
So we take the one out of the 1 5/6, and then would equal 5/6.
That's right.
Because we just minus.
That's all you have left. Yeah. Yes, you're right. Now doing that using your number line, you have, look up here. You have 1 and 5/6. You're going to take away 1, which we know is the same as 6/6. 1, 2, 3, 4, 5, 6. And that's going to land you right on 5/6, which tells us that all 3 of these diagrams are
Correct.
Are the same, are correct. 11/6 minus, so we have 11/6 minus 6/6. 11/6, 6/6 lands us on the 5/6. 11/6 minus the 1. We know that 1 and 6/6 are the same. So we're going to hit that 5/6 again. Eyes up here. Now, this is what Garrett was saying. I kind of cut him off on purpose because I wanted to make sure we knew exactly what we were doing before we used this trick, because this is a trick. Look at what he did here. Garrett said 1 and 5/6 1 and 5/6 minus 1. You know what he did? He was like 1 and 5/6 minus 1. There you go. I'll minus the 1 right there. Just take the 1 off of there. And what does that leave you with? 5/6. It leaves you with your 5/6 right there. So that's a trick. You're right. But we went through the steps to prove why 1 and 5/6 is the same as 11/6 and why 6/6 is the same as 1. Therefore, why all of these are the same. Right? Does that make sense? Excellent. Because now we're going to practice. Use a number line to represent each difference and to find its value. So I'm going to write the values over here. I'm going to write the values over here in this circle, these circles. Right? 8/3 minus 2/3. Does anybody have an answer right away? Ella? Ooh, who agrees with 6/3? Who can tell me how to draw it? You would be correct, Ella. Very good. Who can tell me how to draw it? Get it up here on this number line, Will.
So you would do 8/3. You find 8/3 on the other line.
How do I do that?
You shove like you would count like 3s, and then you would end up with 6, and then you would do 2.
So this is 3/3, right?
Yes.
This is 6/3,
And then you get plus 2.
and then our next two, this is 8/3. Is that what you want?
Yep.
Okay. 8/3 minus
2/3.
how many spaces do you want me to go back?
2.
I'm gonna start here. I'm gonna go back 2, and then I'm gonna land where?
6/3.
6/3, just like Ella said, right? Good job. Next one. Charles?
4/3. 4/3. 4/3.
4/3 is my answer. Is that right?
Yes.
Who agrees with 4/3 is my answer? Aubrey, can you get it on my number line? Where do you want me to start? Where do you want me to start? Right here?
Yeah.
Okay. 8/3. 8/3. Now I have to minus. How many do you want me to jump back?
4.
Huh?
4.
Good. And then I land here on 4/3. Is that right? Do you agree with Aubrey?
Yes.
Good. And finally, 8/3 minus 1. Think about it for a minute. Thirds minus 1. Ashley, what do you think?
I think it's 2.
We gotta figure out what this 1 is. What's that 1, Olivia? Why 3/3? The denominator is a 3, and that tells us that one whole thing is 3/3. So we're going to start at 8/3. How many are we going to jump, Olivia? We're going to jump 3, and that's going to land us where? 5/3. Ladies and gentlemen, that is how you subtract with fractions and number lines. Okay? That concludes our math lesson for today. Goodbye, those of you in the interwebs. We will see you next time. Bye, Beverly.